Okay, so in this video, I'm going to give a walkthrough explanation of exercise 4 and exercise 26. So for exercise 4, the statement for the question is that how does the Turing machine do when given A, 101 as input, B, an arbitrary bit string as input, and the machine is described by 1, 2, 3, 4, 4 different descriptions. So my solution for this question is that firstly, to achieve that, I can get programmatically get a random bit string. I have this function method defined here to generate a random bit string given a length of how long the bit string should look like. So, but it default to 3. So if I call this method, it will give me a 3 number of a random bit string. If I give a number 5, it will give me a 5 number of random bit strings. So to solve this problem, I define a class here called Turing machine. It has 4 initialized property on this class when this class gets instantiated. It has a disk description method here, allows the user to add the 5 tuple description to the machine. And also on each calling of this method, it will also put the first element of the tuple to the non-final states list to keep tracking of whether the final halting state is a final state or it's not, to determine whether the final halting state is a final state or not. Okay, so the second method is the process method. So this process method, it will take in an input string. And this entire method using a while loop here. So the idea here is that first of all, you need to get a reference of the original input string and split the string into a single character list. And then you're starting from index 0, starting from the start state, which is S0, and starting with the first character of the input string. And then the target description, which is the starting description, will be calling this internal method given by the current state and the current symbol. So for this initialized variable here, for example, if we given an input of 101 here, the initial current state will be 0. The initial current symbol will be input 0. For this example, will be 1. And the initial target description for this method that returned will be the first description here as the pair of S0 and should be the starting description should be this one, the second one, as the starting state is S0 and the starting symbol is 1, yes, which is the first character of this input string. And then after initializing the first state symbol and description, it will kick off this while loop, and the program will break out of the while loop only when the program couldn't find the next description, which is a target description. So in this while loop here, it also calls this method here at the end of the looping, the current state and current symbol will get reassigned to both of the variable. So the new current state will be the description tuple, the element at the index of second will be assigned to the new current state. And this entire elf block here will assign the new current symbol. And also inside of this block of code, it assign the next index. I check if it's the direction is right or left. If it's a right, it has additional if-else block to check if it's already out of the range of the original input. For the direction is left, I also reassign the next index and check if it's the next index is out of the range of the original, not the original input here, but the new input split here. And also, for overriding the old value, it has this a new symbol variable to track of the new symbol to be replaced to replace the old one. And at the end, when it breaks out of the loop, it has this hold state and also the tape record being saved into this class, and it will call parse result at the end. The find target description method will find looping through all the description, find the one that has the same value of the state and symbol provided. And parse result will return the string of this final tape, which here will be the tape record, and replace the blank symbol with empty string. That after this the final string will be a more human readable string. Otherwise, it's it also checks if the whole state is inside of the non-final states. If it's non-final states, actually this one should be like this. Okay, so if the whole state is not in a non-final states, which means it is a final state, then we'll say that yes, because I have a string said that it is not final. Yes, so if the whole state is in the non-final states list, it will print out this string. Otherwise, it will print out this string. Okay, so let's rerun this thing from the beginning and rerun this class. So, alright, so for this Turing machine, I instantiate this class and add for description as indicated in the question, highlighted here. After that, execute, check out whether the descriptions already have all the description added to the instance, and we will call this process method to process 101. So it gives us the final tape as 101, and if we and generate a random bit string of length 8. Here, this highlighted here, the random bit string. If we call this process method again, it will give us a one string here. So my conclusion here is that what the Turing machine with the above descriptions, it will convert any number of random bit strings to the same number of ones. So for exercise 26 here, the question is that construct a Turing machine that computes the function, takes in n1 and n2, and gives a arithmetic adding of n1 plus n2 plus 1. So to solve this problem, I referenced the textbook example. It is example 4. So for example 4, I was able to leverage the class that I created here for exercise 4. So I leverage the class, create the instance, add the description that from example 4, the textbook suggested 5 descriptions for solving the simple arithmetic addition of n1 and n2. Then I create these two functions, generate the input representation and generate the output representation. So basically these two methods will take in the number type and integer, non-negative integer including 0, and return the expected input and output string for the Turing machine. So for example 4, after I add all those descriptions that suggested in the textbook, I have this test case 1 that basically saying that n1 equals to 2 and n2 equals to 2. I want this test case 1, the input representation for n1 and 2 to be this string, and I want the expected result to be this string. And then I test this instance that get instantiated from the class I defined above, called the process method, provide the test case 1. So I expect the final type string that returned from this process method to be as the same string that get returned from this get output representation method. Okay, so it is the same string there, so it means that my class definition is correct. And then to solve this exercise problem, so basically to achieve the computing of this n1 plus n2 plus 1, we need to add one additional 1 at the rightmost of the output string. So to achieve that, what we need to do is to add 2 more descriptions to this Turing machine. So basically for the first description, the operation on that description is to do nothing if the entering pair is S3 and 1. The second description is to say that replace the blank symbol with 1 if the blank symbol indicated as B. Replace this B with 1 when the entering pair is S3 and B. So the final state will be S4 after we add these 2 additional descriptions onto the same instance. So after doing that, I have this test expected 2 that call this get output representation, and my test expected to will be a 6 ones, 6 concatenated ones. So if I at this point, if I call a process method again on this instance, because it's already at being added to more description here. So for the same test cases, which is 2 plus 2, it shall return the same string as this method return. It should be a 6 number of concatenated ones. So, oh, now it's 7. Maybe there's something wrong. Oh, let me fix the code and come back. So it turns out if I rerun this kernel again, it just fixed the whole platform, fixed the code by itself. So there is no wrong in my class definition, and also there's no wrong in my description here. Also I created this additional essentially additional instance from the same class just to make sure that these two instances doesn't have any conflicts or any same that will be interact by each other. So the first instance will be the one that the same one to run the code for example 4 from the textbook. This instance will be the one that solves this exercise problem, exercise 26. So yeah, so the final tape return from this process method is exactly the same that to the expected string that generated from this get output representation. So yeah, and that's it. That's the whole explanation, the walkthrough video for challenge 6.